Hi, welcome to my video on the instantaneous rate of change, word problem number 3. Again, I said I was going to do a few examples, and the more examples that you see done, hopefully the more you'll understand. And this one has the height, ht, which is a negative 4.9 t squared plus 40t, represents the path of an object in the air, where h is the height in meters and t is the time in seconds. Find the speed at 2 seconds. So the speed is the rate, and because they have 2 seconds, this speed, we could say, is the speed average, or is it instantaneous? Because it's at one time, the speed is the instantaneous rate of change. Again, if I had the speed from 0 to 2 seconds, it would be the average. But because it's at just 2 seconds, it's the instantaneous rate of change, which is the slope of the tangent at 2 seconds. And we have, let's see, we have the time is 2 seconds. Now I want to explain a little bit about this equation here. This is the height in terms of time. Height is a function of time. But if you think about it, this is like a parabola, and the parabola is negative, so the parabola is going, if you think about time, you got time and you got height, so this is a parabola, and if you let the time be 0, t is 0, that means the parabola is starting, this object is going up from the ground, so the object is going up like this and hits a certain height, and then it comes down like that. So what we're going to do, we're trying to find the time at 2 seconds. So this 2 seconds could be right there, 2 seconds could be over here, 2 seconds could be here. It could be here at the vertex or here. But let's see what it is. Now we have 2 seconds. Now, no, what you don't know, or you might not know, I shouldn't say don't know, is that if you double this number here, negative 4.9 doubled, that's 9.8. Negative 9.8 is the meters per second. That's the as you say, the force of gravity acting against the object, bringing it downward. And the 40 here is the velocity that this object is going up in the air. So as it goes up at 40, as soon as it leaves, its velocity is going to, or speed is going to slow down because of the gravity pulling against it. And this is the force of gravity pulling against it. So here it is at, let's say that's 2, let's say it's here. So we have 2 seconds, and we're going to get close to the 2 seconds, so we're going to add on 0.001. So we're going to find the rate for these 2 times, and because they're very, very close, we'll come up with the instantaneous rate of change, which is the slope of the tangent at the time of 2 seconds, and the slope of the tangent will be at this point here, if it's on the way up. So let's put 2 seconds in here. So the h of 2 is negative 4.9 with 2 squared plus 40 times 2. So when you work that on your calculator and plug it in correctly, you got to use it, type it in. This is a negative number, so be careful, don't put in a subtraction sign. So when you put all that in your calculator and work it out, you get 60.4. And it's the height, and so that's in meters. And when you do it with this one, you get height of 2.001. So you're plugging in negative 4.9, 2.001 squared, add on 40 and 2.00, just long way to write it out. And again, be careful plugging this in, but when you do, you will come up with 60.420395. I write it down all the digits, and again, this is height in meters. And so the speed is the instantaneous rate of change. So the speed, instantaneous rate of change at this one point, the speed is, and I just forgot to write out, this point is 2 seconds, 60.4. This is 2.001 seconds, and we get 60.42. So I just want to make sure I write it down as two ordered pairs. So the speed is y2, which is 60 point, right here, 4203951. Y2 minus y1, x2 minus x1. And again, when you plug this in a calculator, put a bracket here, type all this in, put a bracket, division sign, bracket, type this in, bracket, and when you do, this will work out to be 20.3951, and so to the nearest unit, it's 20. And it's a speed, velocity, so its velocity is, the height is in meters, and the time is in seconds. So it's changing at a rate of 20 meters a second at 2 seconds. And if you had different times, at 1 second, you got a different rate. At 3 seconds, they got a different rate. And from 0 to this time here, it'll go up, hit the maximum, and come down, hit the ground at this time. Again, if you took this equation and let the height be 0, you could work out these values for t. And one of them is at 0. What's this one? By letting the h of t equal 0 and solving this, you would get the answer when the object hits the ground right there. So that's another problem done with the instantaneous rate of change. And again, the more problems, the more you'll help you understand. Click the like button if you wish, the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.